Hi friends, many people remember the video in which I showed a parcel with all devices, among which was this nice IPS-1 power supply. In general, the history of my acquaintance with these blocks goes back to the beginning of the 2000s, when I first had a chance to see and to work with such a block. I immediately fell in love with it and after many years even repeated the circuit of this source. But all this wasn't enough and in the end I bought it. The block is practically from storage. The condition is perfect and today I intend to make a full review of it for you. IPS-1 is a laboratory-regulated DC source produced in the USSR. There was also a Mars power supply and the IPS themselves could have minor differences, in particular in appearance. These sources are very nice, compact and very good in terms of circuitry. It has protection against short circuits, have the possibility of coarse and fine adjustment of the output voltage. It doesn't take up much space and the output parameters are enough for many laboratory tasks. On the front panel of the source there is a small pointer voltmeter. Next to it is a power switch with an incandescent indicator lamp. Just below a pair of knobs for coarse and fine adjustment of the output voltage. At the very bottom are the output terminals. The housing of the device is made of tin but has a beautiful painting. On the cover we have a bunch of holes for natural cooling. They can also be seen on the rear panel and on the bottom. At the rear panel we have a fuse box, ground terminal and mains cable. The device was released in 1990 and then it cost 25 rubles, which was quite an adequate cost for such devices. For comparison, a digital portable multimeter electronics MMTs-01, which in terms of its functionality is like the DT830, at the end of the 1980s cost 125 rubles and this was a huge amount. For many people it was a whole monthly salary. According to the characteristics, this device can be compared with PS1502 power supplies. The output voltage is from 0 to 15 volts, despite the fact that it is stated on the front panel from 2 to 15. The output current is 1 ampere. There is current protection, or rather current stabilization. If, for example, you close the output, the voltage will immediately drop to almost 0 and the current will be limited to 1 to 1.2 amps. The instability of the output voltage isn't more than 1% when mains 220 deviate by plus minus 10%. Ripple output voltage no more than 20 millivolt. Power consumption from mains no more than 55 volt ampere. The weight of the source is about 2 kg. We will test it today, but before that, let's open it to study the feeling and for prophylaxis if necessary. Inside everything is very beautiful. At the bottom there is an iron transformer large enough for a 15 watt. At the back there is a radiator with a power transistor. The control board is located on top. There are no microcircuits here and everything is assembled on transistors. The printed circuit board is small in size, made of Gettinex. Actually, high-quality printed circuit boards of any size and complexity will be made for you by the sponsor of this issue, GLC PCB. The company has a huge production capacity and your orders will be processed and implemented in the shortest possible time. Complex multi-layer boards, high-quality plating, different board thicknesses, and a large selection of track coatings and solder mask colors. All this you will get at humane prices. You can find the link to the GLC in the description. Let's return to our unit. The assembly is neat, the wires are fastened with threads. There is a couple of rather capacious electrolytes for power. In principle, they should be replaced, as well as the electrolyte on the control board. But so far everything is working and the ripples are basically small. I will leave it as it is, because I'm too lazy to re-explain how the circuit works. There will just be an insert from the video where I already did it. This is a circuit. Unit is built on 6 transistors, 5 of which are low power. The power transistor is composite and according to the circuit it is KT829. But I installed a much more powerful legendary KT827, also a composite reverse conductivity. I have minor deviations from the circuit which don't affect the work. We have 4 variable resistors, 2 of them are trimmers, the rest are designed for coarse and smooth adjustment of the output voltage. The first resistor is responsible for limiting the current, a kind of current protection. If desired, this resistor can be brought out. In this case, we will get the ability to limit the current manually from the panel. The original circuit is designed for an output voltage of 0 to 15 volts and a current of up to 1 to 1.2 amps, and believe me, this is enough for most tasks. But the power of the circuit can be increased by replacing the power transistor and reducing the resistance of the current sensor. The second trimmer will allow you to set the upper limit of the output voltage. It should be borne in mind that the output voltage of the circuit is always less than the input, in this case by 2 to 3 volts. The reference voltage source is assembled on a pair of KT315, KT361 and a linear diode. Further, the output voltage from the reference source through the divider is fed to the amplifier cascade. The current limiting circuit is as old as this world, a current sensor in the face of a low resistance resistor. If the load draws current above the set limit, the lower transistor will operate, as the voltage drop across the current sensor is enough to open it. Following it, the second transistor will also open, which will mute the signal on base of the control transistor, and it will start to close, and therefore the output transistor will also close. Well, now let's test it. So we put the plug into the outlet, start the source and check the accuracy of the output voltage setting, not forgetting to set the voltmeter needle to 0 if necessary. In general, the accuracy isn't bad and everything is regulated normally. Fine adjustment makes it possible to change the output voltage within 1 to 1.5 volts. The source isn't afraid of short circuits. In this case, the voltage drops to almost 0 and the current is limited to 1.2 amps. Now let's check the stability of the voltage under load. We set the output voltage of the source to 12 volts. It is displayed by the lower voltmeter. There is a resistor, the resistance of which is chosen so that when powered by 12 volts, the current in the circuit is about 1 ampere. The flowing current is shown by the multimeter on the right. When the load is connected, we see a voltage drop in the region of 60 millivolts, which is quite good for this baby. Under the same measurement conditions, 12 volts at the output at a load current of 1 ampere, the voltage ripple didn't exceed 60 to 65 millivolts, and that's peak value. The RMS value is about 4 to 5 millivolts. Oscilloscope bandwidth is 60 MHz, filters off. There are a little more ripples than there should be, but this can be blamed on electrolytes. The block is more than 30 years old, so that's forgivable. Well, another power supply has been added to my collection. I was really looking forward to it, and this unit will definitely take pride of place among other devices in my retro laboratory. This video is coming to an end. Please don't forget to rate it and share with your friends. To keep abreast of events, you can find my other resources using the links in the description. Now, I say goodbye. Until we meet again, with you as always was Kasyan TV.